Our next speaker is a Rails developer, plant mother, and beginner woobler. I won't spoil the surprise, ask her about it. She enjoys all that can be revealed from seemingly simple places when you approach them with curiosity. She enables creators to make their dreams a reality via crowdfunding at BackerKit. Please welcome Sweta Sanghavi.
A couple years ago at BackerKit, we set out to build a crowdfunding platform. We had been downstream of these creators for over a decade, but we had actually never enabled them to run their campaign on our software. And so we set out to build a product competing with a first-to-market established competitor. And lucky for us, we already had a creator interested in experimenting with us. But that also meant we had to be up and running in several months for when they wanted to launch. We needed to build everything from a new way of handling payment processing to routing within a new engine within our Rails monolith. We were transitioning BackerKit from a B2B to a B2C product. At the time, this felt audacious, it felt scary, it was stressful, but also exciting. A chance to build in a new space, solve new problems for new customers, and leave all our gnarly tech debt behind. While there were some unexpected hiccups, the whole team did catch COVID at the onsite in which we started building this, Rails supported us putting up new user flows relatively quickly. We launched our first customer on crowdfunding by BackerKit as scheduled, and the project funded. Soon, other customers were lined up to launch on BackerKit. New customers with new requirements, new customers that found new bugs, and we needed to iterate on features that we had already gotten out there to build them further and build out new ways to engage with backers. However, as we started to build out this platform, we started to hit some roadblocks. We were attempting to push many new features as fast as we could to get user feedback on our product, but soon features took a lot longer to get out to customers. Initial patterns that had served us well to get up and running served us less well as time moved on. As developers, we're constantly working in the pressures of production, weighing speed to release and taking the time to write well-factored code. Today, we'll talk about how we can continue to retain speed in development by better using a simple tool, our familiar friend, the plain old Ruby object. Welcome to Plain Old But Mighty, leveraging POROs in Greenfield and legacy code. I'm Sweta Sanghavi. I'm a New York transplant living in sunny Oakland, California, here to tell you pineapple does belong on pizza. I'm a tech lead at BackerKit, where we build tools for creators to have their best crowdfunding campaign yet, and also support them in fulfilling these campaigns and getting their rewards into backer hands. Also living in Oakland is my firstborn, Morty, who today will double as my pair. Morty is a staunch proponent of the PORO in his code, and hopefully we can all learn something from him today. Today, we'll start out by talking about what a PORO is, how to use them to grow Greenfield code, and how to use them to rein in legacy code. In the next half hour, I aspire for us to all become better at spotting opportunities to leverage POROs and shipping more extendable code, whether it's for new or existing features. So let's start out with what is a PORO. And I hear Morty meowing for attention. Morty, what is it? Oh, Morty has an answer for us. A plain old Ruby object is just an object that does not inherit any functionality from Rails. We get a lot of great features from Rails itself, but at today's RailsConf, we're talking about code that does not inherit from Rails. We can write better Rails code by leveraging POROs to encapsulate data and methods in our Rails app. And so, simply put, we're talking about simple objects with no additional bells and whistles from Rails. It's really just Ruby. And while POROs may be simple, let's not let that deceive us that they are unimportant. POROs help us factor our code to more object-oriented design. They afford us flexibility in building out our code, give us a usable API, and support faster testing. So let's see how. First, let's talk about using POROs to grow Greenfield code. When we're building new features, this is often high churn code, since many of the requirements are still unknown. This code is in development, and POROs allow us to continue to grow this code. So everyone put on your BackerCat hats, and let's look at an example from BackerKit. First, a little background on the app we're building on today. BackerKit is a crowdfunding platform in which creators will launch projects, like a new fantasy role-playing game. Projects have funding goals, and backers can back these projects for rewards. If enough backers are excited about a project and back it, the project funds are collected, and the creator can use those funds for production. So let's pick up the next ticket in our queue. Well, BackerKit is going to launch 100 pin projects at the same time for the first time ever for an event called Pintopia. If all the projects get funded, backers who've backed will get a commemorative pin. And the future request is to celebrate this event or track its progress. We're going to have a little progress bar on project pages so that backers can know what % of projects have been funded, and even a funded count on the bottom left. With, in this example, 89 out of 101 projects were funded. So let's start sketching this out. Let's add this feature to our code base. And all right, Morty, your turn. You're going to write us a red test. Morty's pulling up our project controller spec and writing a new test in the show action, since this new feature is going to be displayed on project pages. And that's where we expect this progress bar to be displayed. We're going to start with a pretty straightforward spec. So we're going to have a funded and not funded Pintopia project. And when we make a request to the show page, we expect the body to have that 1 out of 2, that funded count that we saw on the bottom left of our component. All right, let's get Morty's test to pass. We're going to open up the show action, and we're going to need a way to represent this new event, because we're going to need to get the funded count for our new component. Since this is a one-off feature for Pintopia, something that's really new, I'm pretty resistant to doing anything too committed for now. So I think I'm just going to store the projects participating in this event in a const in an array. And now, because this thermometer should only show up for projects participating in Pintopia, I'm going to ask if the current project we're trying to display is included in the event, just checking the const for that project ID. All right, so next we're going to need a component to display the progress. And looking around the code, I find a view component we can use called progress component. The progress component takes 3 parameters: a title, the progress, and the total. And we can sort of think about it as a numerator and denominator represented by progress and total. So I can think of a title and our total because our const that represents the Pintopia projects, we can just get its length. So the last piece we're going to need to display this component is the progress. So the last thing we're going to need is to get the count of funded projects. And right now, I'm just barreling towards a green test. I'm not going to think too hard about how we accomplish this. I'm going to iterate through the projects that are participating in Pintopia, use the scope method that I found fully funded, and count the number of funded projects. And so I'm going to add that to our controller code. So if our const includes the current project, so if this is a project that's part of Pintopia, we're going to instantiate this instance var event progress component that will represent what % funded or how many funded projects there are in our event. All right, Morty's going to render this view component conditionally in our show action and pull up the tests. We're also going to add a little stub for the const so that we can assert that the 2 projects we've added actually are going to be returned by our Pintopia project stub. And let's run our test. All right, we got to green. Amazing. So let's go take a look at the trade-offs we've introduced in our show action. Well, number 1, we have a green test. And so we have delivered the functionality that was required from this feature. And getting to a green test, it revealed what unknowns and requirements we were going to need. until we're green, we actually do not know if we've actually accomplished the task. And so refactoring prematurely is not what we're going to be doing. And because we have this green test, we sort of know what requirements this new domain concept needs. We need the number of funded projects. We need a way to check if the current project is included in this event. We need a name, and we need a project count, the denominator. Now you can imagine that I kind of have this faux example, and there's a lot of other code in this show action for project show, and we've added quite a bit of new code into this controller. You can also imagine if we never do this event again, this code is going to be living in this controller forever for every new developer that goes to extend this code. If this is early in this controller's lifecycle, we may not really notice the impact of this kind of code, but in future changes as code grows, this is going to start getting in the way and adding even more code in this show action. How can we instead use a PORO to support this new feature? We know that we have this new domain concept, this idea of multiple projects launching at the same time. So what if we represented that with a new object? I'm going to name it event project to kind of represent that it's an event. And let's move our specs to a new spec for a new PORO called event projects. We basically already have the interface of what we need for a new object because we saw it in use in the controller code. And so I'm going to have funded projects, and name. And we'll have these unit tests kind of sketched out pretty straightforward, where funded projects returns the funded projects that are funded, projects returns projects, and name just returns the string Pintopia because we needed it for our view component. So let's see what it's like to get this test to pass in a PORO. Now, notice this exercise is largely just moving controller code into a new file, a new object called events projects. I moved over our const just as is. I gave it a name that's really just hard-coded to the string that I need it to return right now, and moved the projects method where I iterate over the const to grab the projects, and then I use that same scope method we saw for our funded projects method. One last thing we said we needed is also a way to check if the current project we're displaying this page for should be rendering this view component. So even that code can be handled with our new PORO. What if we accepted a project and had a method that returned true or false if the project was participating in Pintopia? And we can leverage that same projects method that we already wrote, and we can conditionally set an event progress view component method, which conditionally returns that view component or nil, based on if the current project that we've passed or the project that we passed is a part of the event. As I'm encoding this, I'm realizing the only feature requirement I have thus far is just conditionally rendering this kind of progress bar. So I'm going to move the rest of the methods to the private scope and only expose this event progress view component as its public method. So let's kind of take a look at the PORO. And one thing I'm noticing is it's still pretty simple. It takes a project and has just one public method. But it provides a place for future changes to event project to live. We can imagine that perhaps there will be some future use cases for even those private methods, and some of this code can change over time. Let's take a look at what the controller looks like with this new object. We can see it's way more simple. It's really just one line in which we set an instance var to the return value of event progress view component. And so really our view code hasn't really changed. Our instance var can either be nil or the event, the progress component that we want to render. This code now better adheres to the single responsibility principle. Our show action is still more focused to the components needed to show this project page, whereas the project event is the one that's responsible for knowing when to render this component and any other information to support what's required to render that component. We've also gotten way more flexibility with this refactor. POROs introduce a new seam into our code. And the definition for seam that I'm using when I say that is a place in which we can alter our behavior in our program without editing that place. Another way to express that is the open-close principle, which says that software should be open for extension, but closed for modification. And so in our case, our team members should be able to add new functionality to our system without changing the existing code. We could change any of the innards of events project, and our controller code would remain the same. Let's say there's going to be a new case in which we do or do not render that component. We don't really need to make any of those changes in the controller, and the event project could handle any of that new conditional logic or future abstractions. Leveraging POROs gives us seams to invite simplicity in our design. Our controller gets to be pretty simple, whereas the event project can continue to be refactored if it needs to be used for additional requirements. This supports our code staying cheap and easy to extend and modify. POROs also give us something to wrap our uncertainty in and allow our code space to evolve. In Greenfield code, POROs can serve a really important function. When we wrap business logic in a PORO to represent a new domain concept, we get to quarantine that uncertainty and hard-coded bits in one place. Those hard-coded strings and arrays can exist in our PORO, whereas outside the project, we actually don't care how funded projects gets evaluated. Inside the PORO, we can grow the code we need as new requirements come in. Sometimes we need to have tolerance for some uncertainty to wait for the right abstractions to show up in our code as we extend it. But in the meantime, having a fence around this code makes it less painful to wait for future examples like the next event or the next time we're going to need to change this code. Let's say when we first got that feature requirement, we actually saved it as a model. The thing is, we don't actually know the attributes of what events projects is going to need until we get more requirements, future events, etc. And we expect to have unknowns at the stage in which we have the first event. Changing table names and column names and managing downtime list deploys, these are not things I'm interested in worrying about the first time we're adding this feature. And so with this PORO, we've gotten the API we might want from a model, but decreased the cost of waiting. This PORO is also designed with our current use case in mind, but we can make any changes to the interface with the new object easily. Furthermore, our half-baked PORO with these kind of constants and hard-coded strings signals to the reader where this object is in its development. We're not as set in stone as a model may imply. Until I have a requirement that I cannot fulfill without a new table, I'm very happy to wait at this state. Our PORO also supports faster and simpler testing. When we refactored our tests to our PORO, we no longer needed to load our app, Rails, or Gem to actually test our code. Previously, when we were in the controller spec, we actually were making a request to action and asserting something on the response. That's a pretty expensive test. However, now that we're in this PORO, we're going to have really cheap unit tests, and we can just load in what we need to run our tests, like RSpec, etc. Our test suite is faster, and we've refactored integration tests from a controller into unit tests. Our controller spec will also be way more simpler and won't need to instantiate any test data. It will just expect to get a different response from event project and conditionally set that instance var. A really straightforward, faster test. Lastly, we get a semantic, easy-to-use API. POROs can give us ergonomic features based on how we need to use it and how we compose the methods, even the public and private scopes that we've added to it. We can also add fun little syntactic sugar if we end up needing to call certain methods a lot, so we don't have these long lines of code in our spec or in our code. We can use POROs for wrapping APIs, for example, with more semantic words and method names that pertain to the domain we're using them in. POROs enable us to design our code in flexible and composable bits. It actually wasn't so difficult to go from where we were cramming our code into our controller into a new object. The most difficult part is just choosing to find a new object or thinking of a new object when we're trying to build more extendable code. And so if we continue to practice this, long term, we'll add our more flexible code. Next, we're going to talk about legacy code. And there may be some few different definitions of legacy code, and so I've put some on the slide here. So code that the original developer no longer maintains, code that's no longer engineered but continually patched, or untested code. The first bullet passes the buck to someone else at one point knew what this code was for, but they're no longer here for one reason or another. Show of hands, who's ever annotated or git claimed some legacy code that's hard to understand, only to find that developer was actually you? I also thought it was interesting that this is code that continuously needs to be patched, but there is no easy abstraction or designs to extend it. So this code can be really resistant to refactor, especially when untested. It's often code that everyone's scared to change because we know there's important functionality, but we can't understand it. Well, how did we get here? Code attracts code. A new feature request comes in, we look around the code base for code that's adjacent to what we're trying to add, and we just stick the new code in there. We often put more code where code already exists, and if there's some gnarly conditional, well, what's one other else if statement? Unfortunately, the natural tendency of code is to grow bigger and bigger, and at some point it tips, and the complexity is so large that you can't actually even imagine putting the code somewhere else. There is no useful design to extend. Poorly factored legacy code that's hard to use is often demonized. However, often this code is stuck around because it continues to serve a purpose. It reflects constraints that were there at the time of writing that code, written when requirements and unknowns were still being discovered. If we're finding ourselves extending this code, it's probably high churn and worth an investment. I think a lot of times we resist refactoring this code because we don't have a lot of tools to start unspooling this ball of yarn. And this is where POROs can be so powerful. It gives us small things we can do within the life cycle of shipping a feature to start unspooling legacy code. So let's go back to our own app at BackerKit and talk about how we can lasso our legacy code with our mighty PORO. So we're going to take a look at our pledge controller. Making a pledge is one of the main parts of our app, so it being unwieldy is not super surprising. Here, it does not even fit on one slide, but let's see what we're doing. So before this code excerpt, we're saving some attributes onto a pledge. And we can think of pledge.confirm as basically just saving the pledge. And then if we're successful, we're going to do some things and redirect, and otherwise, we're going to do some other things. This is really just a wall of text. I don't expect you to read all of this, but we have all these things that need to happen once we save our pledge successfully. When scanning this code, and I'm trying to extend it, it's pretty hard to tell what's going on and what's important for it to happen right at saving a pledge. If we put our archaeology hats on, we can imagine how that we got here. We got a ticket that was like, I want to show star backer status after somebody pledges. And so a reasonable developer looks at the seam in which after we create a pledge and sticks one more thing in there. We see a bunch of service objects already instantiated in this create. So there is some design here. When I look at this code, I see two kinds of things happening. Setting of instance vars that we need in the next action or in the next user view, and some kind of side effects or data changes that need to happen to support user flows. Well, I'm going to use my del tool again, and I'm going to take a bunch of this procedural code that's not key to the render redirect logic and put it in a plain old Ruby object. On scanning the method calls, I see that the arguments for these methods are often project, user, and pledge. And so I'm going to see what I can quickly move over to a new service object. So let's create a new service object called pledge creation service with the parameters of user, project, and pledge. And really, I just moved a lot of that code to this new service object with a call method. If we look back at the controller, I still needed to leave a bunch of code already in this conditional, but we did kind of half this part of the conditional branch. I would argue even the small change of a new service object that's not even factored made a positive change in the design of our code. We can leverage POROs to add small stepwise changes that gives us something to do to leave the code a bit better than when we found it. We've provided a breadcrumb for the next developer to come in and iterate on this further. With this change to the controller, the primary purpose of the controller is way more clear. It's to create the pledge and redirect the user to the pledge show. When we adhere to that single responsibility principle, we get the benefit of making the code more clear for what the primary purpose of the action is. So when somebody goes to extend that code, they get to basically ignore all those side effects unless they actually need to look into that part of the code. We also get to use a more usable API. So once I took a look at my service object, I could bucket what's going on into these 4 buckets: create followers, backfilling some data, creating badges, and sending some mailers or notification. Once I had narrowed the scope of the code I was looking at, I could more easily reason about it, and it was a really reasonable next step to start naming these in more usable methods. And so at a glance, I could glean what happens after creating a pledge more easily when I pull up the post-pledge service. Introducing POROs and refactoring objects also give us opportunities for decoupling. After I moved the code into a service, I could better see what the dependencies of it actually were. Specifically, when I looked at the mailer that we were sending, when the pledge that was being created was the one that got the project funded, which is very easy to read, obviously, from that code. But it was when I started to decouple or try to move that worker into my service when I better could understand what the requirements were. And so this slowly gives us a better surface area to start refactoring some of the complexity from the code and also decoupling some objects from it. Once I kind of made that realization, instead, I thought that we could set a var called newly funded that basically just evaluated to true or false. Instead of passing the previous kind of gnarly code into our service, decoupling that into just a simple bool will make the service object more usable. When we're doing these refactors, we want these inner objects to know as less as possible or be as loosely coupled to the code that's calling it as possible. And so by saving this to just a true or false value and passing it into the service, we also can support the separation of concerns and will make more reusable code. In the future, if the way we're evaluating that last parameter, that true false value changes, the service object underneath it will not have to change, which will make making changes way faster. So this is using that newly funded. So now we're going to accept newly funded into a service object and just ask that conditional whether or not we should send that email. I also noticed that we could key a lot of what we needed off of pledge. And so we can just pass pledge to our service object and instantiate the backer and project inside the service object. Introducing a new object for future extension or modification. The service object serves to introduce a new object for future extension. The next developer that comes in has a better place to extend this code and no longer has to contribute to the ball of yarn that's already existing in this controller action. This technique can also be useful for untested code. We can sprout a new class or method from existing code and test just that object within a block of untested code once we break dependencies from the existing code. On that note, let's talk about approaching untested code. POROs can also give us a strategic way to deal with code that we hope never to have to work with, but they provide a defensive way to chisel out a tested seam and chart a path forward. Most legacy code is riddled with dependencies, which is often why adding a test harness around some portion of untested code can be so difficult. We need to break dependencies before we can introduce those tests, but breaking dependencies requires us to change code without the safety net of those tests. So a good method we can use is change as little code as possible to get those tests into place, break those dependencies, and then write tests and then make the change. However, sometimes we don't have the time or context to break dependencies, and we can leverage POROs to get out of a bad dependency situation of code that we can't get into a test harness. Let's imagine we've gotten a story to extend an existing feature that allows backers to pay an installment to charge their remaining balance. Under the hood, some data updates need to happen that are managed by the scheduled payment manager. The new feature we need to enable is inserting some logging so that we can have a paper trail to changes that were made to a payment or a charging schedule. The problem is the manager is complex and we don't have time to understand all its components or its integration with charging. And the kicker, it's untested. Well, POROs can help us chisel a path forward with minimizing the debt, even when we don't have the time to break dependencies and refactor big, complicated, untested classes. They can serve as a strategic defensive strategy when we can't bear to add any more to that existing class. Well, let's see how. First, let's identify the method that we need to make this change. And so I've done that. I've noticed that consolidate due balance is the code that is allowing folks to charge their remaining balance and the code in which we're going to add additional functionality. So let's pull up the scheduled payment manager. And we have that consolidated due balance. In this case, this is untested, and there's even more complexity that we don't see in this code. We could just add logging to the existing place and kind of run away. When I tried to TDD just that feature, I could not break it out of the dependencies already in the code, and so I couldn't just test that feature or just the logging part. So instead, we're going to introduce a new class for this behavior, and we're going to call it logging scheduled payment manager. We're going to need it to respond to all the same calls of the original class. And so I'm just going to extend scheduled payment manager so it can still respond to all of the same methods. We're then going to accept the existing object, that scheduled payment manager, into our new class, the logging scheduled payment manager. We've now created a new class in which we can eventually use to behave the same way as the scheduled payment manager. However, in this new class, we can actually add the new functionality and TDD it out in a new method. So let's add a log scheduled payment change method and actually test drive this part. We've now carved out a spot in which we can add a new method without contributing to that bad dependency situation we found ourselves in within a reasonable amount of time investment. The next step would be to actually call our new method, our log scheduled payment change, in a method named the same as the method we were trying to extend in the scheduled payment manager. Lastly, we'll actually call that existing method the consolidate due balance method. Now, our wrapper class, the logging scheduled payment manager, can behave the same as our scheduled payment manager and share an API with the existing object, in which it will consolidate due balance, but also have the additional logging behavior we need. The last step is to call our wrapper class, the logging scheduled payment manager, everywhere we were calling our scheduled payment manager. And this should just work because it has the same API as the existing object. The code's not going to know that it's actually getting a different object. So what did this give us? This example is called the wrap class technique. And to underline, this technique is specifically for when we're in a bad dependency situation. we can't decouple these dependencies, whether it's because of a lack of time or context. And this is really helpful in situations where we don't want to extend an existing class that already has a pretty independent behavior, or the class is so large and we don't want to make it worse. This may feel like a pretty big change to our code base, and it can feel like we've added even more complexity with this new PORO that accepts the existing manager. However, the truth is there is plenty of complexity hiding within this neat method, and we could have added more to it, and it actually would have been adding more untested code. In return for this additional complexity, though, we have a narrow slice of tested code. Sometimes the biggest thing that gets in the way of difficult to refactor code is just the amount of complexity in our way. And providing a small incremental improvement or a path towards a better place, leaving a roadmap to the rest of the team, can actually be a really important step. It gives us some tools to start untangling that complex, untested code. Sometimes that trade-off includes adding complexity to get where we're trying to go. As we make these incremental improvements as we change code, we must have patience for those interim steps that we have to live with for a while as we chart forward a path to breaking those dependencies and refactoring legacy code. This is an excerpt of a talk, All the Small Things by Sandy Metz, in which Sandy walks through refactoring, simplifying some code in these interim steps. And in those interim steps, we can see that it doesn't always feel like the code's getting simpler until the end. When we're committed to object-oriented design, we must have that faith that we are moving towards more simplicity and know that the complexity along the way is worth the trade-off for that end state. The truth is, we don't always have the time in one ticket to do all these interim steps, but we exist in a deep developer ecosystem. And sometimes taking one step sets the path for the next developer and come in to go to the next step. On the journey of small steps that we can take as we're modifying code, POROs are our mightiest tool. The beauty of POROs are they provide a simple delineation or seam in our code. And they provide strategies for growing Greenfield code within classes that are still evolving. They allow us to extract domain concepts that are easily mutable. Leveraging POROs allows us to set patterns that help us break large complex classes into smaller objects with less coupling. When tackling legacy code, they allow us to refactor out objects that we can then use facades or patterns to build even more flexible code that's faster to extend and deploy. POROs give us a new start, sometimes in a literal file, but metaphorically a decision point, a new seam for modification. So the next time we're wrestling with new or existing code, I hope we turn to our simple, plain PORO and work towards leaving our code base a little bit better than what we found it, and inviting seams of simplicity into our design. Thank you so much for coming to Plain, Old, But Mighty. I don't have time to be taking questions here, but I'll be hanging up here or in the hallway. Else, if you have thoughts or questions, feel free to email or DM me. And no, all complaints or critiques will be managed by Morty. Here are some of the inspirations for my talk, and I highly recommend the Michael Feathers book I have at the top. He lays out a lot of different strategies for dependency breaking techniques for legacy code. And thanks for everyone who gave me feedback on my talk, including my dad, who's here for his second RailsConf, so give him a round of applause. Thanks for coming.